Hey folks, this calculus lesson is called Antiderivatives, and this is the algebra part. The next lesson will be the trig part. Antiderivatives is just undoing derivatives. Remember when you take a derivative, you subtract the exponent? Well, to undo it, you add the exponent, except you have to do a little bit more to that. So recall if you had functions at x cubed or x cubed plus 5 or x cubed minus a half, and I took the derivative of those. The derivative of all those would just be 3x squared because the derivative of 5 is 0. The derivative of negative 1/2 is 0. So when you take the derivative of a constant, that's okay, honey, come on in. When you take the derivative of a constant, it becomes 0. So when you see this derivative right there, you don't know what the original function was right here. So what we're going to do is we're going to call f could be some arbitrary constant. It could be a half, it could be 7, it could be 5, it could be anything. So the original of all of these right here, 3x squared, came from f to be x cubed plus some constant. We don't know what the constant is. Okay, so notations, you guys, given your function f of x and your derivative is f prime of x, and your antiderivative is capital F of x. Okay. And so when we're requesting the antiderivative, capital F of x, the process is represented by the integral symbol, which is this little snaky sort of symbol right there. And it's in the shape of an S because it's representing the summation symbol, and that'll be coming up soon when we start integrating in between two numbers here. So the integral of f of x dx is, remember, this is the antiderivative of f of x, and then don't forget the plus c. A lot of students forget your plus c, where c is any constant. So we'll have several examples to do this. So rules for integrating, you guys. If I did the derivative of a number, the derivative of a number equals 0, so the integral of a number is just some number. Okay, I'm sorry, the integral of 0 is just some number right there. Okay, second rule is this: if I took the derivative of, say, 5x, okay, then it would just be 5, right? Because you have 5 and then you make it x to the negative, or x to the 0, which is 1. So the integral of that number is, you just go backwards. It's going to be the number x. So the integral of, say, 5 would be 5x, but it would be plus some constant right there. Okay, you'll see. I have several examples. Okay, and if I have the derivative of, say, like x to the 5th, the derivative of x to the 5th would be 4x to the 3rd, because, I'm sorry, 5x to the 3rd, sorry. If this was x to the 5th, the derivative would be 5x to the 4th. So this would be my 5, and this would be 1 less than that. So the integral, we go backwards. Instead of subtracting an exponent and multiplying by the number, we add an exponent and we divide by that number. Okay, don't forget your plus c. All right, let's try some of these, you guys. So find each indefinite integral, and they're indefinite because we don't know the plus c part. Well, that'll be in a couple lessons from now. Okay, so the integral of 5, I kind of talked about it up there. Okay, so it's going to be 5x plus c. Okay, just imagine if I said take the derivative of 5x plus some number. It'd be 5. Okay, so it's undoing the derivative. It's antiderivative. All right. So don't forget your plus c on these, you guys. I'll get a handful of kids. They'll turn the test in, and they always forget the plus c, and I ding them points. And they say, but you know, it's the plus c, and I say, you're right, it's plus c. You got to don't forget the plus c. I know your calculus teacher will do the same. All right, so the integral of 10x. Okay, so what derivative did I take that gave me 10x? Okay, so it's going to be so I'm going to add an exponent and divide by that exponent. Okay, so add, this is a 10x to the first, so add an exponent and divide by that exponent. All right, so I get 5x squared plus, whoops, I didn't even finish that, darn it. This should be, let me type that in right here. It should be 5x squared plus c. Okay, that's what this baby should be right here. 5x squared plus c. Squared, let me backspace, plus c. That's the answer right there. Okay? All right, because 2 goes into 10 that many times. And imagine if I said take the derivative of 5x squared plus some number right there, it'd be 10x. All right, easy, huh? All right, how about this one? Okay, so just add an exponent, divide by the exponent. Don't forget your plus c. All right, there's your answer right there. Okay, how about this one? Add the exponent, divide by the exponent. Don't forget your plus c. Easy, isn't it? See, I told you guys to get the hang of it. And if I took the derivative of this, it would get me back to this right here. Remember, the derivative of any number right there is 0. All right, so the antiderivative is not as accurate as your derivative because you don't know what the exact original function was. We don't know what this plus c stuff is right here. Eventually, in a couple of lessons from now, we'll be able to calculate what c is. Whoops, that's a W-H-A-T. Sorry, H-A-T. What c is, and instead of subtracting the exponents with deriving, we always add the exponents and put that number underneath in the denominator. All right. So how about this one right here, the integral of 1 over x cubed? Okay, that's equal to x to the negative 3, and then add an exponent and divide. So when I add 1 to that, it becomes negative 2 and divide by negative 2. And then since it started with this in the denominator, let's go ahead and put this back in the denominator. So that's going to be a negative 1/2 or negative 1 over 2x squared. Don't forget your plus c. All right, how about this one? Write that as an exponent. Okay, so x to the 1/2, and then add an exponent. So and then divide by the exponent. So it's going to be x to the 3/2 divided by 3/2. Okay, and let's put that back in radical form. So a fraction that's in the denominator, it inverts and multiplies. So 3/2 in the denominator becomes 2/3. Okay, times the square root. Remember that 2 means square root right there. That denominator in the exponent means square root. All right, now what they might do is make a pair of x's on the inside come out. So you might see 2x root x. Okay, either one of those is great with me. So when you're looking at the back of the answers, you're playing the multiple choice game, you find the appropriate one that matches that. All right, let's try this one here. Okay, so this is just as easy. Okay, so I'm going to add this. It's going to be 5 divided by 5. Add this exponent, 3 divided by 3. Add this exponent, 2 divided by 2. Don't forget your plus c. Okay, so there's the antiderivative f of x, capital F of x. All right, how about this one here, last one? All right, when you have a fraction and you have bits and pieces on top, then make each top piece over the denominator. Okay, so x over root x plus 1 over root x. Okay, and then this is x to the 1, this is x to the 1/2, so x to the 1 minus 1/2 becomes x to the positive 1/2, and this one's x to the negative 1/2, and then add an exponent, divide by the exponent. Don't forget your plus c right there. Okay, all right, and then go ahead and flip them up, and there's your final answer. All right, that's easy enough. Tomorrow or the next lesson, sorry you guys, is going to be on trig, and if you're in my calculus class, I would assign that for your homework. Take care.